So today, go over homework 5.1.3. So it says Adriana had to find the inverse function of f of x equals x minus 3 squared plus 2. She got the equation f inverse of x equals root x minus 2 plus 3. So will her stack function machine work? So use Adriana's idea from problem 5-41 to verify that the functions are inverses of each other. So basically you want to plug like one of the functions in the other. So just like you can plug in this function here for x into there. So then you'll get parentheses root x minus 2 plus 3 minus 3 squared plus 2. So I plugged this whole function in for x here, and then you have minus 3 squared plus 2. And then if they are like inverses of each other, right, then everything should be undone, and then you should just get x. So right away, like these plus 3 and minus 3's cancel, so then you get root x minus 2 squared plus 2. And then the square root and the squared cancel, and then you get x minus 2 plus 2. And then those cancel, and you get x. So, like all operations came undone. So, inverse. Verified. Okay, Adriana's friend, Symmetra, decided to check f inverse of f of negative 5. What happened? And why did this happen? Okay, what she should get, so f inverse of f of negative 5, right? We talked about this in example in the video. Like if you plug in negative 5, and what this means is she's plugging negative 5 into f and then plugging that answer into f inverse. What she should get back is negative 5, right? If this is a true inverse, right, then she should get back her original answer, right? Because these undo each other, right? So let's do that. First, we want to find f of negative 5. So, right, we plug that in to f. So it's negative 5 minus 3 squared plus 2. So that's negative 8 squared plus 2, which is 64 plus 2, which is 66. And then she plugs that into f inverse. So f inverse of 66, right, we're supposed to get 5, right? That's what we're supposed to get. So then you plug in 66 minus 2 plus 3, right? That's the f inverse function. And then you get square root 64 plus 3, which is 8 plus 3, which is 11. So that's not 5. Okay, so the problem is because this function here, f, is a parabola like that, right? Its inverse is like a sideways parabola, but this function here is actually just this half. So that's why. So this f inverse is only half of the original, like half of the inverse of the original function, right? This is f of x. So to restrict its domain, we need to find out what that vertex is, right? Which is 3, 2. So then the restricted domain so here's that part's F inverse. So we want to just make half of the upwards parabola. So here, so we just want when x is greater than or equal to 3. Okay. So it says, Adriana and Statler are writing inverses of some other functions. They come up with the following inverse pairs. Help Adriana and Statler verify whether these pairs of functions are really inverse of each other. If they're not, explain what went wrong and write the inverse functions correctly. State the domains and ranges necessary to make each pair of functions inverses of each other. Okay, so basically, to check to see if they're inverse functions of each other, you want to do what we did here. Plug one of the functions into the other. It doesn't really matter which one, but just, for the sake of consistency, I'm just going to keep plugging in the top one into the bottom one. Again, it does not matter. So I'm going to plug in, so you want to plug in this in for x here. So then I have 5/3 and then 3/5 x minus 15 plus 25. Right, so there's my 5/3. And then you distribute these, right, and then you'll get 5/3 times 3/5 is 1, so you just get x, and then 5/3 times negative 15 is negative 75 over 3 plus 25, and then that is 25. So then you get x. So they are inverses. Okay, so same thing again. Want to plug the top one in for x here. So then you get 2 over x plus 10 minus 10. So plug that in there. And then you get 2, and then the plus 10 and the minus 10 cancel. So you get 2 over x. And essentially that's 2 divided by 2 over x. And then that's really 2 over 1 times x over 2, right? If you if you divide by a fraction, you flip it and multiply. And that's 2x over 2, which is x. So these are inverses. Okay, next one. Again, we're going to plug the top in for x here. So then it's 4 times the square root of x minus 10 squared over 4 plus 10. Okay, so then you get 4, and then you can split them, remember, over, you can only split it over division or multiplication. You can't split it over addition. Okay, so then you get 4, and then that becomes x minus 10 over 2. And then you get, then that cancels and you get 2 this turns into 2, and then you get 2x minus 10 plus 10. Right, which is 2x minus 20. Okay, so these are not inverses. Right, I'm only supposed to get x. See? Not, because everything is supposed to come undone. See, only some things came undone. Right, the square root and the squared went away, but not everything. Okay. Okay, so I'm going to plug this top one in to the bottom, or for x into here, right over here. So, oh yeah, let me just like highlight this. So then you get cube root of cube root of the new x, which is that whole function, minus 1 over 2. So then you get the cube root of 2x minus 1 cubed, and then the 7 minus 1 is 6. And then divide by 2, that becomes a 3, so then you get x minus 1 cubed plus 3, plus 7 on the outside. Okay, and the cube root, if this 3 wasn't here, it would go, this cube root would undo this, but this, it doesn't, right, remember I said it doesn't split over addition, so you actually can't do anything anymore. So these are like not inverses either. Sad face. Okay, so the rules were, if they're not, explain what went wrong and write the inverse function correctly. So let's do that. So let's start with, so e, for this one, e of x is x minus 10 squared over 4. So that's y equals so then you want to flip them and solve for y. So we'll do it over here. I should like highlight this too. Inverses, not inverses. See, so then you get 4x multiply by 4, you get 4x equals y minus 10 squared, and then you square root both sides. You get plus or minus, and then that's plus or minus 2 root x. So that was her problem here. She had a 4 root x and not 2 root x equals y minus 10. So y equals plus or minus 2 root x plus 10. That's the correct inverse function. Okay, let's do this one. So we'll switch x and y now. So you get x equals 2y minus 1 cubed plus 7. And then again, solve for y. So subtract 7 first. So x minus 7 equals 2. And then divide by 2. Then cube root it. So our real inverse function is y equals the cube root of x minus 7 over 2 plus 1. Let me make this a little better. More organized. Oops. Well, looks ugly as all hell, but whatever. Okay. I'll watch you guys like faster, like, oh, I'm sorry, I'm over you trying to make your thing look pretty. Whatever, it's fine. Okay. So there we go. This is the correct inverse function. Okay, moving on. My beautiful coffee stain. It says, to what power do you have to raise? 3 to get 27. So it's like 3 to the what is 27? Right? 27 is 3 cubed, right? Because 27 is 3 times 3 times 3. So the answer is 3. Right? So 2 to the what is 32. Right? It's 2 to the 5th. Right? Because 32 is 2 times 2 times 2 times 2 times 2. Five to the what is 625. It's 5 to the 4th, right? Because that's 5 times 5 times 5 times 5. I'm just like, I have these memorized, guys. That's just because I'm a boss. Okay, now this is important. So it's like 3 to the what is 27, 2 to the what is 32, 5 to the what is 625. If you notice, 3 to something is a bigger number. So if you have something, some number to something and you get a bigger number than that original thing, like 625 is bigger than 5, 32 is bigger than 2, 27 is bigger than 3, right? Then your exponents are all going to be like numbers bigger than 1. But since it's like 64 to the what is 8, right? Then my exponent is going to be smaller than 1. And remember how exponents work. Like, remember that like something to the 1 over a is the same thing as the 8th root of that. So basically, what root of 64 is 8, right? It's the square root, right? The square root of 64 is 8. So then it means 8 to the 1/2 is your x value. The same thing, so here, like 81 to the what is 3. Right? You also think it backwards. 3 to the what is 81. 3 to the 4th is 81. So then 81 to the 1/4, right? The 4th root of 81, right, is 3. And here, 64 to the what is 2. And just get 2 to the what is 64. 2 to the 6th, right? 2 to the 5th is 32. 2 to the 6th is 64. So it'll be 64 to the 1/6. Right, x squared to get, it's like to the what is x to the 1. Right, it needs to be, you basically, remember how exponents work, they multiply. So it's basically 1/2. Okay, there's a typo here, I kind of mentioned it. I have a sticky 3 on my computer, unfortunately. So it's just x to the 3rd. So x to the 3rd to the what gets you x to the 12th. Again, so you multiply. So it's like basically 3 times what is 12, right? So this is 4. And then here, again, x to what is x to a? The question mark is just a. Okay, and then it says, Kirsten was working with a function machine, showing it right, but when she turned her back, her little brother Caleb dropped in a number. She did not see what he dropped in, but she saw that it fell out a 9. So, what operations she must perform onto 9, what her machine did, use this to determine what number dropped in. Okay, so machine was like initially added 5, and then square rooted. So that's the order of what her machine did. So to undo what the machine did, you have to undo in like reverse order. So then her undo, you need to square and then subtract 5. So this is machine. This is the undo machine. So then she has to square 9, right, and then subtract 5. So that's 76. And then you can double check your answer, right? If you plug in 76, are you going to get 9, right? Square root of 76 plus 5, right? That's 81. You get 9. Works. This is your check. Okay, write an equation for a machine that will undo Kirsten's machine. So here we have square root of x plus 5. So we want to undo it. So it's x equals square root of y plus 5. So then it's x squared equals y plus 5. And then subtract. So y equals x squared minus 5. There you go. See ya!